this is file number 2 for Math 107 for homework over Chapter 6. Here we have more parabolas again. Obviously, what kind of parabola is this? Sideways. Alright, but let's do it as though it's up and down just because I want to show a point. Here's the general equation. Alright, and that's going to be an up and down parabola. So I'm just going to draw it like this. And I want to show something on it. Alright, the distance to this focus, the distance from here to here is P. Alright, what's the distance all the way across? Now if you want at right angles here, this distance, which doesn't look like it is the way I've butchered up this drawing, that's 2P. Okay, let me try to do a decent drawing here, which will probably be impossible for me. Okay. Alright, now let's say the vertex is at 0, 0, and the equation looks like this. Okay, x squared equals 24y. That means that 4p equals 24, or the distance to the focus is 6. So if I want to get to the focus, I would go up here to 6. This is my y-axis, here's my x-axis. So I go up 6 here. That's where the focus is. But if I went straight out here, I would encounter the parabola at 12. This distance is 6, going from here to here. Going from the focus out, directly out at right angles here, to the edge is 12. Same in the other direction. So this parabola will go like that. It's a very wide parabola, right? Well, didn't even make it there. Okay. Oh, that is just shameful. I have to bear that shame there. Okay, so it's 6 out to the focus, and if you make a right angle over here, it's 12 out to the parabola, because whatever is here, it's double to get out to the edge of the parabola. Right? So now you know something about this particular parabola, but on the next questions they say, what happens to the focus if the parabola is flattened? Alright, I'm going to make another attempt. Alright, here's the point. There's a relationship between the width of the parabola and the distance to the focus. Let's look at the middle one. If the distance from this vertex to the focus is 2, then the distance out to the edge is 4. Now say you have a case in which the focus is now at 1, then the distance out to the edge is only 2. And if you went up here to say, whatever this is, 4, then the distance out here has to be 8. So if you have a wider parabola, the focus moves out. If the sides are squished in, the focus moves in more towards the vertex. Now the remaining 4 problems have to do with the standard equation, which I went over a little bit earlier. So the standard equation looks like this. ax squared plus bxy plus cy squared plus dx plus ey. I don't care about this part here, so it's alright if it gets scrunched, plus f equals 0. That's a standard equation. The non-standard equations look like this. X minus 4 squared over 36 minus y minus 2 squared over 16 equals 1. That's a graphing friendly form. And as soon as I look at that, I know a lot about it. I know it's a hyperbola. I know it opens sideways. I know that when I draw the fundamental rectangle, it's going to from the center, and the center of this hyperbola is 4 and 2. I know I have to go plus or minus 6 off that center in the x in the horizontal direction to draw the edges of the fundamental rectangle, I have to go plus or minus 4. I'm taking square roots here, vertically from the center to draw the fundamental rectangle. So I have all this information from that graphing friendly form. But in this case, with the standard equation, which is this one, I don't have so much information. I would have to complete the square to get from here down to here. But before I do that, I can eyeball this equation and figure out which conic section I'm going to get: a circle, an ellipse, a parabola, or a hyperbola. And I do it by looking at only two of the coefficients, the a and the c. And there are certain rules for this. So this happens even before you complete the square. If a and c are not 0 and they're equal, and they're not equal to 0, it's a circle. All right, so you're looking at the coefficient of x squared and the coefficient of y squared. B I put up here for completeness. We don't include b in this class. What b does is rotate the conic section off of the axis. So instead of being totally lined up in the x and y axis, it might be at, say, a 45-degree angle or a 60-degree angle. And that's what's reflected in the b. We're not worried about that. Now we're just going to look at the a and the c. If the a and c are not 0, they're still not 0. Oops. A isn't 0. C isn't 0. But they're not equal to each other. But their signs are the same. The sign of A is the same as the sign of C. There's a lot of conditions here on this. That's an ellipse. Right? So if they're equal and not 0, it's a circle. Again, if they're not 0, but they're not equal to each other, but their signs are the same, it's an ellipse. So we have the same conditions again. If A is not 0 and C is not 0, but the signs are different. The sign of A is not equal to the sign of C, I'm sorry. Then you have hyperbola. Okay, and then the last case for parabola, either A is equal to 0 or, and that's exclusive or, C is equal to 0. Then you have a parabola. Okay, what happens if A and C are both 0 and B is 0? 0, 0, 0, what have you got? Now it's a line.